All right, so GPUs. We're diving into the world of GPUs today. I know a lot of you out there are really into how tech is changing. And this is one of those things, it's like quietly changing everything.
Yeah.
And we're not just talking about making games look better.
Right.
Although that's fun too.
Right.
We're talking about GPUs being the powerhouse behind this whole AI revolution.
It's true. And it's like amazing to think about how this has kind of come about, because for the longest time, GPUs were seen as this niche component, mostly for like gamers and stuff. And now it's like, they're core part of scientific research, self-driving cars, you name it.
It's everywhere.
Yeah.
So, okay, for anyone who's maybe not totally up on their jargon when it comes to tech, let's just start with the basics here. What exactly is a GPU? How is that different from like the CPU that I always hear about?
Right. Good point. So in the simplest terms, you can think of a computer's CPU as the brain, right? That handles like all the general tasks, runs your operating system, kind of keeps everything ticking. The GPU, though, that's like a super-powered artist. Like it excels at handling these complex visuals and calculations and doing a lot of them at the same time.
So the CPU is busy thinking, the GPU is over there painting a masterpiece.
Exactly.
I like it. Okay, that's a good way to kind of put it in perspective. But what makes it so good at handling these really complex calculations, especially when we're talking about AI?
It all comes down to this thing called parallel processing.
Okay.
So CPUs, they're great at handling tasks one after the other in a sequence, right?
Right.
Like imagine a chef carefully following a recipe step by step.
Okay.
GPUs, they're more like having a whole kitchen full of chefs working together at the same time.
So instead of waiting for one chef to finish each dish, you've got a whole team going.
Exactly.
They're all working in parallel. It speeds up the whole process.
Exactly. And that's what makes them so powerful for AI because especially with things like machine learning, you're talking about massive amounts of data.
Oh, yeah.
And you need to process it really, really fast.
Give me an example. How does that actually work, like in a real-world scenario?
Okay, so imagine you're trying to teach an AI to tell the difference between, let's say, cats and dogs.
Okay, yeah.
Which, by the way, is way harder for a computer than you'd think.
Right.
But to do that, you need to feed it thousands, if not millions, of images.
So it learns by example, just like a child would.
Yeah.
Seeing enough pictures to tell the difference.
Right. But each one of those pictures, each analysis, involves tons of calculations.
Wow.
A CPU, that would have to go one by one, like our single chef working through that recipe. But a GPU with parallel processing can analyze many images at the same time, like our team of chefs, all working at once.
Right. Makes sense.
And that drastically speeds up the learning process.
So that totally makes sense, like giving an AI a massive brain boost. But where do we actually see this playing out beyond just like the lab setting? You mentioned self-driving cars earlier.
Oh, yeah.
And I'm really curious about that.
Yeah. So think about all the data a self-driving car has to process every single second. Like you've got sensors, cameras, GPS, all of that. It's like this constant flood of information.
It's making millions of little decisions in real time just to keep everyone safe on the road.
Exactly. It needs to happen instantly.
Right.
That's where GPUs are key. They've got the power to analyze all of that in real time so the car can, make those split-second decisions, avoid obstacles, and hopefully get you where you need to go safely.
That's incredible. I mean, it really shows you how important this technology is becoming in our lives, everyday lives.
Right.
But it's not just about self-driving cars, is it?
Oh, no, not at all. I mean, the applications here are so diverse, it's really pretty amazing. Healthcare is another really good example. Imagine being able to analyze, like, medical images, X-rays, MRIs, things like that way faster and more accurately than we ever could before.
So instead of doctors having to go through all those scans by hand, you're saying AI, powered by GPUs, can help speed up diagnosis, treatments, all of that.
Exactly. And it goes even further than that. Like researchers, they're using GPUs to speed up drug discovery too.
Wow.
So they're simulating how molecules interact, which means instead of spending years in a lab testing out different combinations, they can run millions of simulations, like super fast.
Wow.
And that could totally change how we treat diseases in the future.
It's like we're entering this new era of personalized medicine.
Yeah, absolutely.
But, okay, with all this talk about speed and power, I mean, this sounds almost too good to be true, right? I have to ask, are there any limitations to using GPUs for AI?
you're right to ask that.
Yeah.
Because as powerful as they are, GPUs aren't a magic solution for everything, right?
Right.
Remember how we were talking about their strength being in parallel processing?
Right. The team of chefs all working together.
Okay, so some tasks, though, they're more like if you had a single chef, but they had to create this incredibly complex dish, it's very sequential, where every calculation depends on the one before it. And in those cases, the GPU's architecture, it doesn't give you that same advantage.
So it's kind of like, you got to pick the right tool for the job. Hammer's great for nails, not so much for screws.
Exactly. And, I mean, we also can't ignore the fact that these high-performance GPUs, they're expensive.
Yeah, that's true.
And that can be a barrier for a lot of people, smaller companies, even research institutions.
Yeah. I mean, not everyone's working with unlimited funds for the latest and greatest. So does that mean this tech, it's just inherently limited in terms of who can access it?
Not necessarily. This is where cloud computing comes in.
Okay.
Services like AWS, Google Cloud,
Yeah.
they let you basically rent powerful GPUs,
Oh, okay.
for as long as you need them.
So instead of building your own supercomputer, you tap into the power of the cloud when you need it.
Exactly.
Wow.
And that's made AI development way more accessible.
That's huge.
It's really exciting because it means we're not limited by how much the hardware costs anymore.
It levels the playing field, in a lot of ways. And it opens up so many possibilities. But, okay, this field is always moving, right?
Always.
So what's next? What's on the horizon for GPUs?
Yeah.
It really feels like we're right on the edge of something huge here.
Yeah.
But GPUs are this key that's unlocking all these doors to possibilities we haven't even thought of yet,
Absolutely. And that's what's so cool about it, right? We're not just talking about little by little improvements. It's exponential leaps
Oh, yeah.
in how powerful and efficient these things are becoming.
Wow.
I mean, just imagine what that means for AI, right?
So even more sophisticated AI,
Yeah.
capable of things we can't even really imagine right now.
Yeah.
Where do you see those breakthroughs happening?
One area that I'm super excited about is personalized medicine.
Okay, yeah.
Imagine using AI to actually create treatments that are tailored to your your genes, your lifestyle, your environment.
We're already seeing some of that.
Yeah.
But with even more powerful GPUs, I mean, the sky's the limit.
It's incredible. It's we're talking about all this complexity of human health.
Yeah.
And somehow AI might be able to find these solutions that are unique to each of us.
Yeah.
Are there other fields where this is really taking off?
Oh, yeah. Climate modeling is another big one.
Okay, how so?
So with more power, scientists can create these crazy complex models.
Okay.
To really understand how climate change is working.
Right.
And hopefully use that to figure out how to, lessen the impact, which, that's kind of a big deal for all of us,
Yeah,
right?
that's a big one. It's amazing to think that the same technology that's powering these incredibly realistic video games
Right.
could also be used to tackle something as massive and as important as climate change. It's kind of mind-blowing.
It really is. It
Yeah.
just goes to show you though, right?
Yeah. The ways this stuff can be used, they're constantly evolving. It's a really fascinating time to be watching this field, I think.
It definitely is. And, on that note, before we wrap up here, I always like to leave people with a little something to think about, right?
Sure.
We've talked a lot about the potential of all this.
Yeah.
But I mean, it comes with some big questions too, don't you think?
Oh, absolutely. More power, more responsibility.
Right, exactly.
As this stuff gets, even more advanced, we've got to think about the ethics of it all and make sure it's used for good.
Yeah. So, to everyone listening out there, here's something to chew on. As GPUs keep getting faster and AI gets more powerful, I mean, what role do you want to see these technologies play?
That's the question.
What are your hopes? What are your concerns? It's something to think about. And on that note, I think that's a good place to leave it for today.
Yeah, I think so too.
It's been a fascinating deep dive. Until next time, everyone, keep exploring, keep asking questions, and never stop learning.